Thank you.
Awesome. No, not a problem. Thank you, Kasam. So thank you for everyone for coming. Hi, everyone. Welcome to today's presentation on Azure Data Factory for professionals. Today, we'll talk about how we can use Azure Data Factory to help create and deliver data pipeline for your organizations. And before we dive in, just a quick bio about me. So my name is Wilson Mock. I have over 15 years of experience in IT. I started as a software developer prior to moving into the data space. As Kasam mentioned, I'm currently working as a lead data architect at CAE, where our focus right now is to create data products to help our executive to drive better decisions making in the organization. Previously to that, I worked at Air Canada as a lead AI architect, where we created data and AI products for optimizing flight capacity and a few other pricing models. Lastly, before that, I was a data engineer at Enbridge, where we created an AI product where we helped created a maintenance product for the wind farm. And if you would like to follow me, I can be found on LinkedIn and as well as C# Corner with /Wilson-Mock. Great. So in this presentation, we expect the audience here to have a basic knowledge of Azure and SQL. This session is broken up into two parts. The first part will cover the basic ETL features in Azure Data Factory. We'll cover what ETL means in a little bit there. And then the second session will talk about the mapping data flow, how we can use mapping data flow for transforming data in Azure Data Factory. After the first demo, we'll do a quick 5-minute Q&A sessions and followed by a longer Q&A sessions at the end of the presentation. So imagine a time when your boss asks you to create a report to show him the sales data. This sounds like a pretty trivial task. All the sales information is in the database, so we can just write a simple query like what you're seeing on the screen here. So he wants these reports every day, so we'll run the reports for him after we develop the SQL query. We'll run the report. We export it into Excel for him, and we email it off to him every morning. So the boss is pretty happy about that. He's getting his report every day based on what he asks. And unfortunately, you have to run this report manually every day. So you have the great idea of let's automate this report. So you will leverage Power BI. So you'll create a simple report for your boss. Now your boss is even more happier because he doesn't have to wait for you to run the report, and he can view the report first thing he comes in the morning. So we can see the differences between the sales the store made versus the profit that it makes on every day that the sales happens. Now, this is all great, and the boss now wants to add more information to the report. This time he wants to see how the weather can impact the store sales. This turned out to be a little more complicated than the previous request that he has for you. We could create a script that download the weather data for us. Then we have to massage or restructure the data somehow so that we can send it to our database. We can then push the data into our external weather table in our database. And after all of that, we still have to figure out how we can schedule this job to run every day. And lastly, if something do go wrong, we do have to we do need to be notified somehow through an alert or through an email somehow. So this turned out to be quite a bit of work to create a custom script for just one external data set. Now with ADF, we can actually simplify this problem. ADF provides us a way to create and manage a low-code data pipeline. So a data pipeline is a process where we funnel or extract the data from either internal or external systems. we can also orchestrate the data processing tools, so we can leverage different tools like Databricks, store procedures, or even serverless functions to transform our data. And finally, we can copy or load the transformed data into our designated system. So in our case, this will be database, but it can also be a file server or a separate system where we'll just send the data through SFTP or through an API. In addition to all of that, there's also a scheduling capability that's built into Azure Data Factory to help you schedule your pipeline. And we can also configure alert and monitoring components when the pipeline do fail. So let's apply what Data Factory have for us with the request that your boss have asked for. So first, we would create a pipeline. We would copy the weather data from our endpoint to the landing area of our database. We would use the store procedure to transform or flatten this information so that it can be stored into our SQL database. And then we will load the information into the database. In addition to that, we'll also set up a schedule to run this at 1 a.m. every day. And if there's a failure, we will be receiving an email alert as well. So with that, we will dive into the demo that actually demonstrate this capability. So this is Azure Data Factory inside the Azure portal. And yeah, so we will click on the Azure Data Factory Studio. And in Azure Data Factory Studio, there's 4 main components. There's the home, which is the page we're on now. There's the authoring piece, which is where we will create our data pipelines. There's the monitor piece, which will allow us to create our alerts and also monitor the status of the pipeline. And finally, there is the manage piece, where we will manage our connections to various different services we're connecting to. So this is where we will start our tutorial or demo. And under link service, this is the part where this is the component that allows us to create different connectivities to different services. So in our case, we want to create a service for the weather service that we're connecting to, and as well as to the sales database that we have. In order to do that, we'll click New. And you can see here is a large list of services that Azure has ability for us to connect to. In our case, we will start with the weather service. So that's under file and HTTP for us. So we would call this ls underscore weather service. It is very important to establish a good naming convention when using Data Factory. So in this case, link service, we will use the shorthand version of ls and then underscore the service name that you want to have. In this case, we'll just paste in the URL that we have available. And in our case, this is just an anonymous HTTP request. We don't need to log in or anything. So this is a very simple example of how do we establish a connection string, essentially. We'll click on testing to make sure our connection is good. So Data Factory will actually connect to this endpoint to make sure we get the proper request, proper information to validate our setting is correct. So after everything is good, we'll click on connect. Okay. Now we will repeat this process one more time to create the connections to our sales database. Our sales database happens to be inside Azure, and it is an Azure SQL database. Okay, and again, we'll give follow our naming convention we just have. We'll call it the sales database, and then with ls in front of it. For us, we can see the database right away from our Azure subscription, and we can pick the database name. For authentication, in our case, we'll be using something called Manage Identity, which essentially is a built-in identity that Data Factory has able to talk to the SQL server. So I have done the necessarily permission granting in the database for this connectivity to work. In the case where you do want to use username and passwords, it's strongly recommended that you do leverage the Azure Key Vault integration. And in that case, it will we can store the password in a safe and secure location. Okay, with that, there is a connection being successful, so we will create this as well. There's other connectivity type, so that includes things like blob storage or Azure Data Lake, and some of that stuff some of the components will cover in the second part of the demo, but it is possible to create other services. Okay, so we'll take the rest of the question at the during the Q&A as well. Okay, so we'll publish the changes that we made. So this is a very important step this is a very important step for us, as we want to make sure we don't lose any of the work we have. So we would publish the changes that we created, or the link services that we created. Great. So publishing is successful. So everything, all of our work is safe. So we don't have to worry about losing that information. So the next area we'll go to is the author menu at the top here. And we will, in this demo, we're focusing in the pipeline and the data set items. So the pipeline essentially will be is our data pipeline, and the data set is our data objects. So this could be either the database table, a view, or even the weather data set that we have from the HTTP endpoint. So we will start with that. So we'll start by clicking on the ellipsis and then go new data set. And we'll find our matching connection type that we set up initially. So that's under file and HTTP. In our case, we know our data is a type of JSON. So we'll select JSON. And we'll give it another meaningful name. So in this case, this is a data set. We'll follow our naming convention. We call it DS_, and this is the weather data from the service. And then the link service, we will select the weather service in this case. In this case, since the data is being downloaded from the HTTP endpoint, it's very important for us to import the schema from the connection. So we will set that up as well in here. So after we create the link service, we will be able to see the schema that's available. So we'll click OK there to create this, sorry, the data set, not link service. Okay, so we see the name being created. We have the URL that was shown earlier. And now under the schema, we can see the schema information. So as you can see in this JSON schema, there's nested objects in there, and we need to find a way to flatten this information before we can send it to the database, which we will cover as part of this demo. Okay, so we will also create the next data set, which is the landing area, landing weather table for us inside our sales database. So we will go under Azure, like what we selected before, and we will select the Azure SQL database. Again, I'm just going to quickly apply the same naming convention here. And in this case, we will just call it the sales database landing. We will select the link service and as well as the table name. Can we use Azure AD for authentication? So there's different methods of authenticating. in Azure Data Factory, it is recommended to use managed identity to connect to Azure SQL databases, which it is managed by Azure AD instead of using an individual user to connect. Okay. So the screen act up a little funny there. Okay, so we'll click OK to create this, and we also imported the schema for this table as well, which I created ahead of time. Okay, so we would then publish this information similar to before to ensure all of our work is it's saved and not lost. Okay. You can have as many data sets as you want in a data pipeline. In this example, we primarily only have one data set. In the second demo, we will have a few more data sets that we can use. Okay, so with the two data sets created, I'm just going to close that off just to keep the screen a little more clean. And now we will go into creating the data pipeline. And that we'll go under the pipeline, click new pipeline. And again, we'll follow the naming convention. We'll start with PL underscore. I'm just going to call this demo 1 for simplicity. And we'll close that property tab onto the side there. So our first step here is to extract the data and copy it into the landing weather table. So in Azure Data Factory, this is we need to use an activity to do that. And activity essentially is an action that we're telling the data pipeline what needs to be done. And in this case, we want to copy data. So under the activity, there's a copy data activity. And in this case, we want to really give a good description, a descriptive name. So we will say copy weather data to landing weather table. Okay, we'll also reduce the timeout. So this currently says the timeout will take 7 days. If something goes wrong, for us, the copying the data should be relatively quick. So we will just do 10 minutes. Then we can configure the source. So in this case, our source will be the weather data from the HTTP. There's no additional configuration needs to be done there. And in the sink, we will connect it to the database. So in here, we do have one configuration to make, where we want to make sure the landing table is cleared before it's cleared before we insert any data into it. So just in case we don't have any duplicates or any record that's already copied into the external table, the external data table already. So we would simply just call a delete statement onto that landing table. So we don't. So we make sure we cleaned it up. Okay. So lastly, there's the mapping. As we discussed previously, the HTTP the JSON mapping has a nested structure where in our database is a flat table. So we need to set up the mapping by first click on the import schema, which will allow us to define the mapping that we want. So in this case, we're just going to create the matching names that we have. So I have this is called as source ID, and the date is called weather date. So the problem is also here there's units being reported multiple times. So we want to make sure we rename those columns appropriately. So I have temperature unit, average temperature, wind unit, and speed. Actually, this is called average speed I have. For the clouds, instead of all, we have has cloud. main unit, and last but not least, average per average rain per hour. Okay. So this is the setup we have, and if there's any columns you actually do not want, you can uncheck this for sure. Now, for some complex scenario where there's much more complicated nested object, we can also leverage the advanced editor, which will give us the ability to customize our JSON that we want to copy across. So in our case, we'll just keep it as the basic editor here, and we will go and validate all of our work. So just to make sure that we didn't misconfigure anything and all the settings, all the required setting has been set. Okay, great. So with that, we will again quickly publish all to make sure we save our data in case something happened to the web browser. And after it's saved, we will run debug. So by running debug, it actually executes the code. So we do expect the data to be copied, and it will exist in the landing table in the database, and we will check that in a second. So the table being copied here, oh, looks like we have a failure. So what is this? What is there is, looks like we misconfigured some columns. So let's take a look here, see what was misconfigured. So the best way to do this is to take a look at the dataset schema and try to make sure that nothing was mistyped in here. So let's go quickly scan over this. To make sure I didn't do anything. Okay. Unit average per hour. Spelling correctly. Okay, let's okay, so must have added extra space in the back here, so the type didn't show up. So let's try this one more time. So in here, you will see there's a run ID. So this is the unique identifier for this run. This is how you would, if there's a failure, you will see this ID in an alert, for example. So this is the very valuable information here. Okay, so looks like we fixed the problem and it ran successfully. So let's go take a look at the detail. So as we expect, we are copying the data from HTTP to our database in the Azure SQL database. Okay, we noticed there's the same run activity ID that we mentioned earlier. Everything was good. So one other thing I want to highlight here is the peak connections. So this essentially shows how many, that's essentially show how many processes was used to parallelly copy the data into the database. So we have one process that reads data, and there's two processes to write in order to speed up the process. So with that all copied, let's verify to make sure that our data is actually copied into our database. So we'll check the landing table. So you can see the data are copied across. Our weather data started on February 15th, and we have data until March 22nd. So all this data is now in our database, and so after we completed the extract portion of the ETL, the next step is for us to leverage the store procedure that we have to transform our data. So I wrote up a very small, simple store procedure in SQL Server. So we'll take in two parameters. The first one is the copy date. So we will configure that as a parameter in our pipeline in a little second. So that essentially helps us identify which record, when this record was written into our final destination table. And the purpose of this is if we do have to rerun our data pipeline, we want to be able to clean up this data before we copy the data across on the same day. And the second thing is, in case there is any failure or your boss report any issues, we want to see what pipeline rolled this data into the external weather table. So in this case, we want to track the pipeline activity ID as well. So as we mentioned earlier, we will delete the data first with the same day as what we pass in, and before we insert the data into from the landing database into the designated database. Okay, so with that, we'll switch back over to Azure Data Factory. Okay, so as we mentioned earlier, we want to find a way to pass in the copy date. And the best way to do this is to configuring a parameter for our data pipeline. So in this case, we'll call it the copy date. In data pipeline, there's limited type that we have, so we don't have a dates type here. So in this case, we'll just leave it as a string because of that, and we don't have a default value for this information. Okay, so we'll finish the demo on this, and then we can get into the Azure functions and things like that in the Q&A. So as we mentioned before, now we need to transform our data. So to do so, we need to leverage the store procedure function activity. So that's under general. And we have the store procedure capability here. So we will configure this activity to connect to the store procedures that we have. So here we'll give it a meaningful name, call it transform weather data. Again, this doesn't need to be 7 days, 10 minutes should be more than enough. For our link service, which is our link to our Azure SQL database that we created initially under manage, we will select that as that's the same database where our data is located. And we have this transform weather store procedure that we saw earlier. And as you saw earlier, there are two parameters that is in the store procedure. So we will go ahead and click on import to bring them into the store procedure. Great. So now the two parameters that you saw earlier, as you can see here in the store procedure, it does support the date type, which is what we define in the store procedure. But just do keep in mind that our parameter is a string. So some casting or data transfer, data conversion will need to happen. So in here, we'll leverage the dynamic content. So dynamic content essentially is variables in a lot of the programming language and different standard default functions that Azure Data Factory provides. And in this case, for the copy date, we want to use the data pipeline's parameter copy date. So it's as simple as that there. Okay. Now the copy pipeline ID, it's relatively simple as well, but it is a system variable that ADF provides, as the pipeline run IDs are generated by Azure Data Factory, so they provide that system variable for us. So we will go ahead and pick that as well. Okay, so and then finally, the last thing we need to do is we want to make sure that the store procedure gets run after the copy data are done. So we would draw the arrow to map them together. And again, we would publish to make sure we don't lose any of our work. Okay. And again, we will do debug one more time. And in this case, I'm just going to put in today's date for simplicity as a string, and we'll hit run. So now, after this is completed, we should see the data in our external external weather table that we created. Okay, take a few minutes to complete. Okay, it's relatively quick, so everything is done there. So let's go back to SSMS to double check. So this is our external data.weather, is the table that we want the data to be ending up at the end. So we can see the data is copied based on the data that we put in here, and the pipeline ID are all the same. So if we go back in here, we can see this pipeline run ID is the same ID as this information here. Okay. Now, this is perfect. We're able to develop this data pipeline successfully, but we still have two components left to do, and that's creating a schedule and then creating an alert. And we're going to create a schedule first. So in Azure Data Factory, our schedule is called trigger. So we can go ahead and add a trigger, go new, and choose a particular trigger. So there are different trigger types inside Azure Data Factory. In our case, your boss has asked us to create a trigger based on a schedule that runs on at 1 a.m. every morning. So we will create a schedule trigger essentially. But before we do that, we need to give it a name. So we will call TR for trigger, and then the pipeline name demo1 in this case. So that way, if we ever need to look back, we can always associate the trigger with the pipeline without doing too much searching. So in here, like I said, we'll be using the schedule trigger type. There's also different events or tumbling window that could be used. But for us, just keep it simple, is just go to run at 1 a.m. every morning. So for me, I would be picking this at 1 a.m. in the morning. Okay, for me, I live in Mountain Time, so I will pick that. And the configuration will be once every day. In our case, we're not going to configure any reoccurrence, any advanced reoccurrences, but we can simply also put 1 a.m. here. Okay. You can either specify end day if you have one. In your case, we want to run this every day, so we won't do that. Now, we would like to start the trigger on creation, but in my case, I'm going to disable that for the demo purposes. But we would normally leave this on, so you will actually run at midnight. And we'll click on create there. So the trigger also detects that the pipeline requires a parameter. In this case, it's the copy date, as we saw earlier. So in ADF, in Azure Data Factory, there's also another system variable called trigger.startTime. So in this case, I'll just paste that into this window here. And what it does is the trigger.startTime returns back a timestamp. So in Azure Data Factory, we will format that timestamp into the year, month, day, as we only require the day information, not the time. Okay, so we'll click OK on that. Again, we will publish this information. Great. So now our trigger is created. We do expect the trigger to be run on every day. Now, how do we know if the pipeline is running successful or not? That's monitoring tab is for. So in our case, there's nothing in the trigger pipeline until tomorrow, but you have the same look and feel as the debug one that we triggered earlier. So there was 2 successful trigger that we had and 1 failure that we had. So and that's how where we can see the pipeline runs. So we'll touch on the last bit on the alerting. So under monitor, notification, alert, and metrics. So this is where we will create our alert when a pipeline fails. So we can do so by going new alert rules. For me here, I'm just going to simply call this the pipeline failure alert. So usually you will only have 1 pipeline failure alert rules for your data factory and not tie them specifically for a pipeline. So if a pipeline fail, your boss is going to yell at you. So this is going to be a CEF1 ticket. Okay, and we will click on add criteria here. So there's different conditions you can have for your alerting, including success, failure, something is running too long, or something is running out of memory even. So in our case, we're focusing on the trigger run, which is the schedule run that we have, and when they're failed. We don't really need an email when things are going okay, so just when they fail. So there's also other items you can pick, like fail pipeline run metrics. So when you're doing debug and your pipeline run failed, you will get an email. So for us, we just want to focus on the trigger one, as that would be the one that runs on a nightly basis. Okay, so in here, it gives you a history of all the trigger failure that you have to give you kind of an idea what kind of patterns you want to set up. So in here, the first thing we want to do is we want to pick the pipeline. So most likely we will pick all the pipeline that we want to monitor and all the different types of fails. So this could be either system failure within Azure Data Factory, or you could be something we configure wrong in, let's say, mapping that we saw earlier. So that would be a user error. In the alert logic here, we want to make sure that if there's a failure, any failure, we want to know about it. And the evaluation based on this is how quickly you want the alert to come through. So so you might want to say, if there, I don't need the alert right away. I want to make sure that all my pipeline runs between 1 a.m. and 3 a.m. So I can wait 6 hours before the alert comes, or I can wait an hour to get my alert to see how many pipeline fails. I don't need that I don't need to get that right away. So in this case, you can configure over 1 hour, and your frequency, you will check it every hour. So if you want a rolling window, you can also do that, which means your period might be smaller. So in our case, we want to make sure that if there's a failure, we get it right away. So that's every 1 minute, we'll check over the last minute, and we'll add that criteria. Now, the last piece we need to configure here is the notification. So in Azure, you can reuse your notification if you have set up previous notification. In this case, I have set up an air alert notification, so you can reuse it if you have created one previously for Event Hub alert or Databricks alerts or whatnot. But let's call this something else in our scenario. We're just going to call this Air Alert 2 for the action group name. Use a more descriptive name in your environment. And for the notification, again, this is just email me, essentially, is what I want. And I want this to email to my email address. Now, this could very well be a support email address that you have. If you have a support team that is working with you, so in case you go on holiday, the support team will get the email. If you like, you can also do voice, SSMS, or even an app notification. So we'll add that notification in our case, just email. And we will add this action group. And create the alert rule. Okay, and that is how you would configure an alert in Azure Data Factory. Okay, so with that comes to the end of the demo. We will switch and we will go into our first Q&A. And I saw a lot of message coming through, so I'm going to try to answer them as best I could. Again, just a reminder, we will limit this Q&A to 5 minutes, as there's few more materials we want to make sure we cover off. Okay, so maybe we'll start with Paul while I'm trying to read through all the messages here.
Hi, thanks very much for the demo, Wilson. That was great. I just had one question. When you hit the monitor section and you wanted to test if the alerts and everything went well, is there a means of doing that before actually deploying it, or?
Yeah, you can set up the alert. Unfortunately, you do have to select the pipeline that you want to alert with. So if you do set up the alert first, you do have to come back and make sure that your pipeline is checked to be monitored.
But overall, is there a way that you can kind of test that everything works before you actually put it into practice, like the day of, or for that time? So like, let's say you just make sure that your whole pipeline and everything worked in place, and you set your alerts, but you just want to make sure, is there like a sandbox type platform where you can just test everything to make sure everything executes before you actually switch things? Okay, yeah.
Yeah, so so this is a very simple example I'm going through. Normally, number one, you would use your debug to do your testing, right? And you can even test your trigger. If we go back to the demo for a second, you are able to test your trigger. You can tell your trigger to run now. So that is possible to test not only your trigger, but you can also cause an error in here to cause a failure to make sure emails get sent out. But in enterprise environment, we would expect there is going to be a development data factory and a production data factory, and there will be code deployment that's required to manage that complexity there.
Perfect. Thanks a lot. I'm new to this whole thing, so I just wanted to know how it works. Appreciate it. Thanks.
Yeah, no problem. So to answer some of the questions that we have, what is a link service? So a link service is essentially a connection string. It tells you the server name, if it's a database port, what is your username and password, and so forth. So in our case, we focus on the Azure SQL. We provided that information, and let's say if that information is on premise, then you will have to actually type in the server IP and or the server name and the port number through an internal connectivity. Okay, so the next question we have here is, can we connect Azure Data Factory with blob storage? It requires NEP from no. So you can connect your Azure Data Factory with blob storage or a data lake that we will actually cover in the part 2 of the demo. So we can show that in a bit there. So how do we create managed identity? So when you create Azure Data Factory, a managed identity, or we call it a system managed identity, it's automatically created. So I pretty much went into the database and grant that identity access to the database. Another way to do that is through what they call user managed identity, which is something you create and they behave similarly. But essentially, the main idea there is Azure will manage the service principal key for you, so you don't have to rotate your keys every year or every 2 years. Okay. Yeah, I answered about the AAD authentication. So in our case, in Azure Data Factory, the authentication type is either SQL users or it's going to be through a managed identity or service principal. We do not allow Azure AD users to connect to through Azure Data Factory. We can access as many data sources as we want. In this tutorial here, we are simplifying our scenario a lot more. We're providing the exact table naming here, but in a more complex scenario, we can also leverage the parameter capability of the data set, which will give us more flexibility in terms of what data set is actually being used. The thresholds mean that in our case, in the threshold, when the it's greater than 0, essentially is what we have set it to. And what that means, if there's at least one failure or more than 0 failure, we will get the notification. So I'll try to answer the question there. That might be the last questions we have time for. So in Azure Data Factory, we do have the capability to utilize Azure Functions as an integration. So that is possible. Of course, I don't have that set up right now. And if your database is exposed to Azure Functions, we can definitely connect through that mechanism. Okay. I believe the last thing is the recording, I believe, will be shared on, I believe, on YouTube. Yeah, so will be published on the channel. Okay. So with that, we'll start moving on to the part 2 of the session. Okay. Great questions, guys. Suppose we have so the last questions we have here is, suppose we have multiple data sets with different schema. How do we store them in the database? So each data set would map to each individual table, assuming if you're not using the parameter feature, then your transformation will have to be very specific as what data goes to which data sets or which database table. And we'll kind of demonstrate a little bit of that in the second part of our presentation, of our topic. Okay, so back to the second part of our presentation. Now, so far, our boss is very excited of our work. We're able to, he's able to see the results as he needed, and he doesn't need to wait for us as well. So so he started using the weather data information, and he found it valuable. Now, because of this excellent, great work that we have done, your boss decided to ask you to do more, bring in more data for him in order for him to do better analysis and more accurate analysis for his sales and profit margins. And soon you started running into performance issues. Your data processing is taking longer and longer to process. Everything is currently done at the database level. So of course, going through some digging, you're able to find out the root cause, which is primarily because our database is running out of power. Like, we don't have enough processing power to run all the reports that we have. So the question is, now, what do we do? So, one option is definitely we can go buy a more powerful computer, more cores, and migrate the database to there. That is relatively quite expensive to do that. we can scale up our Azure SQL, in a case where everything is in the cloud. But again, you are paying for that by and large on a 24, on a daily basis. So it's really adding a database power to the database, the best option for us, because we only needed to process our reports. So this is where mapping data flow comes in Azure. So mapping data flow leverages Apache Spark to process our data. The main idea of Apache Spark is to separate our storage with the compute. In other words, we are switching from a database managed processing to a file-based processing. And all the processing will be done in memory. We can scale our data transformation using a cluster of VMs. So there will be multiple VMs in your cluster. So if you need to scale that transformation as you get more and more data, more things to process, that can be easily done. There's no added cost to pay for the database pricing instead of just a general VM pricing. So this is and also finally the similar to SQL, the Spark can also do joins and aggregation that you would do in your report, right? We did summations on the daily sales and as well as the daily profit. So that can be done also in Spark. So things are a little bit different in terms of how we develop a pipeline. So initially we saw the pipeline as a ELT, extract, load, transform pipeline, but instead in the mapping data flow, we will move towards a ELT pipeline. So that's extract, load, and transform. And another difference is that we will extract data from both the internal and external system. So in this case, we will extract all of our sales information as well as the weather data to bring that into the storage so that we can transform them using Spark in memory. And of course, finally, we will generate one table that we will write the data into the designated system. But of course, if you need to write that data out to multiple tables, mapping data flow to support that as well. Okay, so we'll take a look how our data pipeline changes in this scenario. So as we talked about earlier, the extract, we have both the API and the sales database data we need to extract. So in the sales database, there are two tables. They're called sales and sales line, I believe. So both of them are going to be, so there's three tables we're going to be, there's going to be three data sets we're extracting from. We'll write all those data sets into our storage, or in this case, a data lake, which is a type of a blob storage. We will use mapping data flow to read the data from our storage. It will transform the data. If we need to flatten the structure, rename columns, we can do that all as well inside mapping data flow. And then finally, in this case, we will load the data into the reporting layer of our sales database. Okay. So we'll jump back over to our demo here. So in here, very similar to the data factory you saw earlier. I just happen to have a different one, as there's quite a bit of setup needs to be done. So I've done some of the pre-setup ahead of time, but we will go over all the setup that I have done. So first, well, let's take a look at the different link services that we have. So you already saw the bottom two. Those are the sales database and the weather service. So we created a link service that connects to our data lake or a blob storage. So this will be very similar to how we would create how a blob storage would look like. in terms of the link service. So we can go new Azure, and there's a blob storage here, and then there's, in our case, our blob storage is type of ADLS Gen 2, so we would pick the data lake one instead, but you can definitely pick the blob storage instead, and the configuration is pretty much the same as what you saw earlier in the Azure SQL. Okay. So this is relatively simple. We didn't add too much. All we did is added a data lake there. And as we mentioned before, we're going to be copying 3 sets of data into the data lake, and each one of them in this example will be an independent data set. So we have the sales invoice, the sales invoice line, both are coming from the sales database. And of course, the weather data that we copied, I give a slightly different name there. Make sure we prefixed it with, we included a prefix for the connection type that we have. So those 3 data set will be copying the data into the data lake. So in this case, the weather, again, the sales invoice and sales invoice line. Then we would be calling the mapping data flows, and finally we would be writing our data out to the reporting layer, which we just happen to call it reporting sales profit data set. So I just pre-configure all of that so we don't have to sit through and watch me creating data sets here. Okay, so I'm just going to shift some of the elements around. Okay, so pipeline number 2, similar to pipeline number 1, we're focusing on using copy activity. So you saw in the previous one, we're doing the copy activity to the database. In our case, we're copying to the bronze container of the data lake. So all the configurations are pretty much the same here, except that we're picking the data lake as our sink. In the sales invoice and the sales invoice line, it's pretty much the same. Our source is the database that we mentioned earlier, the database table, and the sink is a specific location inside the data lake. So we prefixed it with a sales db /invoice or /invoice line, and then the file that we want the file to be located into. So in our data lake, all the configurations here, we want to make sure our file type is Parquet. And the reason we use Parquet is because this is an open source file type, and that is also great for compressing tabular and JSON data. So you see here we have a compression enabled called Snappy. So this also it's well supported by things like Databricks or mapping data flows for Spark, as it can be read by multiple VMs at a time. So you can scale out processing there. Okay. So let's go back to the pipeline there. So so the first thing I would do, just like we developed this right away, we would run the debug. So in our case, I put a value in here for the copy data, and we will go OK to make sure this runs successfully. Take a second there to copy. And as you can see here, since there's no dependencies on those 3 components, they are all running in parallel. So that's one advantage of using Azure Data Factory. It automatically figures out the dependencies of what you can run together, what you can't. Okay, so before we go anywhere, we're going to take a look at the storage accounts to make sure all the files are actually landed in there appropriately. So we have the sales database and the weather service. Again, we have the weather data that just came across, and in the sales DB, we happen to have a nested structure because we have 2 different data sets underneath, and that's the invoice line and the invoice are also copied across successfully. Great. So now with the data available, we will go ahead and create the mapping data flow. So in here, we'll expand the data flow tab. We can go new data flow, and we'll give a meaningful name in here. We'll call it DF for data flow. So transform sales report. That's what we have. That's the name we want to give. So in here, we can provide multiple sources. As you saw earlier, we will first start with the weather data first. So we click on the arrow, add source. So this is our, we will call this the external weather data or external weather. The data set that we want to have to use in this case is the data lake weather data, not the HTTP one. So just make sure we pick the correct one there. And we will inspect this this data set. So this is the schema that came across through the schema that you imported into the data set. So just be aware that I want to point out the weather date here is actually a timestamp, not a date that we want. So we need to be a little more cognizant of that piece in a second there. Okay. And we will turn on the debug feature, so we can actually see what the data looks like in the data preview. So we will turn that on right now. So as you can see here, we are having a 4-core machine, which is relatively small, and a driver that's also 4-core. That is the Spark configuration that we're using, and we're turning on debug for 1 hour. So we can take a look and see all the data and transformation that happens. So we know what, just in case if we have any error, we can catch them early on instead of try to debug, a code with many different blocks that needs to be, that many transformation takes place. Great. So now with debug started, we're gonna go ahead and refresh so that our data preview will bring in the data. Okay, it should take just a couple of seconds here. Let's try to read the data lake right now. Usually it's a lot faster than this. So just give it a moment to think. Great, so you return back. So pretty much a lot of the stuff we saw earlier in our demo number 1. Again, the weather data, we really don't have a time components of our weather day, but it is detected to be a timestamp. So for us to join our data, we will have to remove this time unit in our joint. So before we can join the data, so we will go ahead and do that first. And to do so, we essentially uses something called derived columns, which essentially creating new columns, either based on existing columns or just in general creating new columns based on a specific logic. So in our case, we will call it the formatting the weather temperature, the weather times stick. Okay, the incoming stream is the stream that it depends on. So in this case, it's the external weather. Okay, and now our new column name, let's call it the new weather date. Okay, and in the expression, we want to build this expression now. So we know that the weather date is a column in our data set. So we will definitely start with that. And in mapping data flow, they have a slightly different syntax than what you saw earlier in the in the data pipeline. So in our case, in order to reformat a day, we need to turn it into a string first, and then convert it back into a date. Okay, so we will click Save and Finish on this. So this, you can see this is imported there, and if there's a typo or something, they will be underlined and alerting you for that error. Okay, and in our case, let's not do a data preview. In this case, we would move towards a select. So in our report, we only really want the weather information, the temperature information. We do not actually want the wind and if it rained or is it a cloudy day or not. So we would exclude all that information and only take the information that we need. Weather temp only. Okay, so in here, mapping data flow is smart enough to bring in all the columns that we have. Again, we have this weather date and also the new weather date we just created. So for us, we really only need the temperatures and the day information. So everything else we do not need. Now I did the reverse. So in mapping data flow, we can check all the columns on the side here, make sure we exclude the 3 columns that we need, and then we can hit delete to get rid of them. And if you messed up, we can always reset this, or you can manually add a new mapping if required as well. Okay. So for now, we will go preview our data to make sure we're formatting the new dates correctly, and we're only getting the 3 columns that we need. Great, all the temperature is Celsius, our temperature value, and our new dates with no times on them. Okay, so the next thing we'll move to is now we need to handle or process our sales invoice and invoice line information. We'll repeat some of the processes there, so that we saw earlier. So in this case, I want to call this the sales invoices, and again pick the data lake data set with the sales invoice. I will also just quickly do that for sales invoice lines, and I'll pick the sales invoice line object there as well. Just gonna fix a typo here. Okay. So there is a relationship between those 2 tables. In the sales invoice, if we look at the inspect, we have an invoice ID, which is the primary key of this table, and there's an invoice date here. But this table doesn't really tell us exactly how much we made for the day and how much sales we made and or how much profit we make. And that information happens to be inside the sales, the invoice line. So if we inspect again here, we can see the invoice ID as a foreign key here. And we have the line profit, which is the profit for this particular invoice, and the extended price, which is essentially the sales price, including the sales tax. So the goal is to merge these 2 data sets together to create a data set that contains the day and the total sales and the total profit that we have as our first initial step. Okay, so we will do this by clicking on the plus sign, utilize the join capability in mapping data flow. So I'm going to call this the sales join. You selected the left stream, which is the one I click on the plus sign on, and in this case, we will select the invoice line. In our scenario here, since we know there's a a primary key foreign key relationship, we'll just do an inner joint as all the invoice ID are existing in the invoice sales invoice table. Okay. So we will be using the invoice ID, as I mentioned before, to join the two tables together. Just be mindful here. It actually indicates the stream name. So in this case, is the invoice, and this is the invoice line. They both happens to have an invoice ID, which is the primary key and the foreign key here. Okay. So as we would expect, this is going to be a pretty big joint, as there's 36 columns together, which is the two columns together. While we wait for this fetch to come in, another way to do this is definitely similar to before. We can do a select to filter out only to the columns we want first. But I just want to show that we can do a full joint if required here. So as you can see, it has all the data information from both tables. Again, the extended price, line profit is what we're looking for, as well as the invoice date, which is at the front of the table here. Okay, so now we have this information. We don't actually have the total for the day. So we have each of the invoice and how much it costs, but we don't actually know for each day how much we're actually making or losing money for that matter. So in order to do that, we're going to be using the aggregate modifier. So this will allow us to do, like I said before, the sum, the min and max, and things like that. So in our case, we will be calling this sales daily profit. Okay, it's based on the joint that we did, and how will we group the data together. So this is, like you would write in a SQL, you would group this data by invoice date. Okay, we're not changing the name, and then we'll switch over to aggregate tab, which we will create two new columns. The first one is called daily total, and the second one is called daily profit. And again, we'll bring up the expression builder here. So we know for the daily total, it comes from the extended price, and the function we want to use it's just like SQL, it's sum. And we click OK on that, and I'm going to do exactly the same thing here for the line profit. And if you don't know, the functions or whatever not, you can definitely, look through this list here, and there's a quick description that comes up when you put your mouse over the functions there. Okay. So we'll click Save and Finish for that one. Okay, now we really should look at what the results look like, because as you saw here, there's 36 columns, and now we should only end up with 3 columns. Hopefully the day, the extended price total, or the daily total, and the daily profit comes up. Okay, so there's only a few rows that came through. That's okay. The aggregation looks to be correct. So now is a good time to add in the weather information together. So right now, we don't really know from our profit margin, we don't really know if weather has a big impact in our profit margin or not. So we need to add another join in here. In this case, we would join the weather into this information. So we will select the weather temperature only. Okay. So in this case, we want to do a left joint because weather is an external data source, is not the most dependable at times. So we don't know if the weather information will come across. And in the case where the weather data information did not come across, we still want the profit information to be shown to our boss. or else he'll be pretty angry with us. So do we pick the left join or the outer join? We can use the join condition here. The sales information is on the left, the weather information is on the right. We want the sales information regardless what happened, so we will pick the left joint. In this case, we will pick the invoice date. Now, remember we did the transformation here so that the new weather date only contains a date information and not a timestamp. So we will be using the new weather dates here as well to confirm that. Okay, so this should be relatively simple. We didn't do anything fancy. Just join the two data sets together and let's see what we get from the data preview. Oh, it's a little bit surprising here. We see no information coming up. Again, we only saw the 5 invoice dates here. And that is because in our debug, it actually limits the amount of data that comes in. So we need to increase this in order to test to make sure our code is functioning correctly. So I'm just going to simply making them 100,000 to just bring in enough data for our query. So you can access it either through this error message here or under debug settings, general, you can also make this update as well. Okay, so I'll go to refresh this one more time, and hopefully we will see the information we are expecting to see. Okay, so we still see nulls, but the error message went away. So let's scroll down a bit. Okay, so looks like we don't have any weather information before the 15th of February, but we do have the information, but we do have the information for the rest of the day up to the 21st. So this is looking good. This looks like exactly what we're looking for. Okay, so the next step here is we need to add in the audit columns, what we did earlier, which is the similar to the store procedure. We have the copy date and the pipeline ID. So we want to do that as well. So in order to do this, we need to configure the parameters to pass that information into here. So we will just quickly call this the copy date. And then the copy pipeline ID. Okay. And in mapping data flow, there is the type for date. So we will be using that. Oh, actually, my mistake here. This actually should be a string, or else the pipeline would not be able to pass that in, because in the pipeline, this is actually just a string. Okay. So we'll fill in a quick default in here so that when we don't have to fill this information in. So we're just going to give it a dummy pipeline ID here, just so we can easily deal with that. Okay, so we will use derived column one more time here. Okay, this is add audit. Okay, and we will have again just those 2 columns here. And again, expression builder, really quickly, we will be including the we'll be converting the string to a date, like we talked about. And for the pipeline ID, it's just a straight a string. So there's we're not doing any transformation to it. Okay, and then we will write this data set out. So we will use the sync, which it's on the bottom of the list. Sorry, I fly through that. The destination is sync, and then this is our sales report. Oops. This is the sales report. Okay, and then in this case, we want to make sure we select the report sales profit from the database, because that's where this data will be ending up to be in. So similar to our demo number one, we need to make sure that we do some cleanup in case if we ran this pipeline before. So in order to do that, we would be leveraging the pre-SQL script here, and we'll add a dynamic content, which essentially I'm just building out my my delete statement with the copy date here, as normally without doing that they won't be able to take in a parameter. So with that, our pipeline is pretty much built, or sorry, our data flow is pretty much built. We would just quickly publish that to make sure we capture all these changes, as we did a lot of work in here. And we will go back to the data pipeline. So this is the one last step we have to do in order before we can test the pipeline, and that's add in the data flow activity. Okay, so we'll add in the data flow activity that's under move and transform, and we want to make sure all the copying is done prior to calling this data flow. So we would call this transform sales report. Again, just going to quickly comfort that. So we get to select the data flow that we have. In our case, we will select the data flow we just built. And in here, the parameter has been lit up, as we have two parameter settings here. So essentially, I'll put in the exact same settings as we did in the first demo. So make sure in this case, we're using the pipeline expression, which is the copy date. And we will be doing the run ID for the also the pipeline expression run ID. Okay, so now we're ready to debug. So let's click on debug. In here, this is our default date, which is fine for this demo. And let this process run through. Okay, this is the outdated one, so just take a second for this. So while we wait for that to come up, I'm just going to deploy my publish my pipeline to make sure we didn't lose any information here. Okay, finally it came up. Just going to do a quick copy, hopefully there. Okay, great. And now it's calling the data flow already. So we can click on the, sorry, jump through that really quickly. We can click on the data flow activity to show what's actually happening in here. So this is still queued. We're waiting for this to run. Oh, actually, it's very quickly. It ran through. It ran through successfully. So 43 rows has been written. So let's check the let's check our database to make sure everything is actually promised. So we'll execute a query in here, and this is the same ID for all of it. Interestingly, none of the temperature came through, so we must have made a mistake somewhere. Let's double check that one more time. See where we make the mistake here. I bet you something we didn't do for the mapping. Yeah, exactly. So in the mapping, we kind of skipped over this earlier. We would delete the primary key column, as that will be auto-filled by itself. So there's a differences in name between what we have derived our columns with what's in the database. So that's why the name are not coming up correctly. So for us, we want temperature unit to be actually temperature value to be the temperature, and the temperature unit to be the unit there. Again, I will trigger debug on this really quickly and publish at the same time. While we wait, we will quickly answer some questions as we're running a bit long on time. So can we go over SCD2 type? So to do an SCD2, it's actually quite more complicated than the data flow we have built. But I believe inside Data Factory, there is a template that you can use. So you can definitely use the a template gallery. And in here, there is an example of SCD type 1, and I believe there was SCD type 2 here. I could be mistaken, but yeah, so it's available. It should be available in here. I did seen it a little while ago. Oh, right here, slow changing dimension SCD type 2. So you can follow this example there. Okay, great. So we will go to the monitor tab. As I've been tapping around, I might have lose the position of the pipeline. So that's another way we can navigate to it, is to the monitor. We can see now, again, the transformation is taking place, and looks like it's done. So we will verify this one more time. Great. So as you can see, the pipeline ID has changed into 4D something or forth, and we have temperature for the invoice date that are greater than the 14th. Basically, is what we saw earlier. So yeah, so that is the second part of the demo on this. So
I had one quick question, Wilson. It won't take
sure.
long. It just has to do with the mapping that you just did. I noticed that because I'm used to SSIS when it comes to mapping, and they would have to be, the columns would need to be aligned. So there was one with the weather date and I believe the temperature date on that screen. And that's when I was wondering, do they have to be when you're showing the mapping section?
Yeah. So they do need to be mapped. So that's why there's this mapping tab here. If the names were not the same, which is the first, when I first did the first demo or the first debug, that's why the temperature was not written. So we had to select the proper value there. Again, that you can add your own mapping, or there's advanced mapping you can use if you need to do that as well.
Okay, so it doesn't need to be specific. It's just based on the situation why it's there, but it will obviously it's still going to work.
Well, when in the sync, we selected the data set for the database, and it knows the schema of that information, right? So it knows what's on the right-hand side.
Microsoft Remote Desktop. Your session was disconnected.
Okay. All right, thanks.
Okay. Yeah. What's the difference between SSIS, Azure Data Factory, and SSIS? My understanding is in Azure SQL, they don't have SSIS anymore. So, and yeah, so that's, but in Azure Data Factory, we could call SSIS from on, if you have SSIS on premise, so we could call that. But just be mindful that SSIS, it is processing data in the database, and in this example, we're trying to pull that out of the database and to use Spark to process our data. Okay. So yeah, just a quick summary here. Today we learned that Azure Data Factory allow us to create and manage a low-code data pipeline. It still require a little bit of SQL, but for the most part, it's relatively straightforward. There's three major steps that we go through: extract, transform, and load. And Data Factory support both ETL or ELT processing. We have a built-in scheduling, monitoring, and alerting capability. In mapping data flow, it allow us to transform data using Spark, very similar to Databricks, except it's going through the GUI UI instead of we have to hand code the transformation. The main advantage of using Spark is to decouple our storage with our compute. It allows us to scale our computation using a cluster of virtual machines, and we're able to manipulate and join our data similar to SQL, and as well as produce your data set for your report using Spark. Okay. Any other questions? All right. If there's no more questions, thank you everyone for attending this session. Hand it back to you, Kasam.